Whenever you're ready, we can be set up.
Ready.
How's the drive over?
It's easy in the morning.
Yeah, it's like 20 minutes.
Less of it.
I think, well, I think keep going. To the right. Yeah.
You have a mouse that I can control the PDF from here? Or,
Yeah, I'll get it for you.
Okay, it's easier instead of bending over.
Yes. If Yossi, maybe move 1 second.
Tell me
Look at
where.
the camera. Move it, drop this way. Perfect. Thanks. Your side.
Can I move in? Move in as I go?
Yeah.
Okay. Oh. Okay, now where is the actual
So
file?
we don't even have a PDF reader. So
It's on internet?
It's internet, yeah. But
Okay,
it's
perfect. Can I zoom it up? Here. Beautiful. Schmack.
yeah.
Geschmack.
Morning.
Oh. Okay.
We put it back onto the Zoom. I will get the YouTube live down.
This brings down to a science. No? Like,
Good morning, Chapetr.
Good morning. What is Alec?
Amazing yesterday. Amazing.
Are you doing screen shares today?
My pleasure. Yes, I'm doing screen shares.
Danny, we got the projector.
Oh, it's on the other seat.
If we sit here, you'll be able to, I mean, wherever you want.
Bad idea.
And this will go automatically?
No, I'll click it. Click the history.
What, using that phone stand here or
No. Yeah.
not?
No, I've been off.
Huh?
All right.
It's 5:45. We're ready to go?
Yes, we're ready.
Okay, can I take this off the screen? I just see the Zoom.
Yeah, just minus it.
Oh, no, but I need this over here.
No,
Can I
think,
Can I go to a different tab or?
yeah, drag it out.
Oh, separately?
Yeah, there you go.
If I keep this up here,
What do we want to do side by side?
no, that's fine. This doesn't disturb them seeing me, right?
No.
Okay. Good morning. We are doing today's Shleisha Prakim Rambam Hilchas Kidush Hachodesh, Perek Yud Beis, Yud Gimel, and Yud Dalet. I want to spend 3 minutes on a quick introduction that if we follow this, we're going to have literally a very easy time making it through today's Prakim. First thing is as follows. The question at the heart of all of these halachas is, will we see the moon on the night following the Moiled? That's the question. The moon and the sun are going to meet up at one point in time. The following night, after the sun sets on the horizon, are we going to have time to see the moon? Or is the moon still too close to the sun that once the sun sets, the moon's going to set too on the horizon and we're not going to see the moon? That is the operative question in these halachas. And of course, the simple answer to find
Depends.
is that depends. And it depends on the distance between the sun and the moon. So you have to find the position of the sun. You have to find the position of the moon. And depending on the distance between them, you'll know your answer. If they're far enough, then you're going to have time to see the moon in the sky. If they're not far enough, you're not going to have time. What are the steps, though, to figuring out the position of the sun and the moon? So in the Rambam, there's essentially, I can boil it down, there's 3 steps. There's 3 steps to getting your answer. The first thing is as follows. We know the daily rate of progress of both the sun and the moon. It means we know how fast they're moving in their own orbit from west to east. So you have to get a starting point, know where the sun was at a certain day at a certain time, and based on the daily rate of progress, reach your day, and you'll figure out where the sun and the moon, where the sun and the moon is. Same thing. You find the daily rate of progress, and you know where they are for the beginning of your day. Then you have to adjust for the view from Earth. Yesterday we saw how the sun's orbit is off center. The moon's orbit also is, which means you're going to see it at a bit of a different angle when you're looking from Earth. So you have to adjust for the view from Earth. And the final thing, and this is going to come up in the end of today's Rambam, is you have to adjust for the time slightly after sunset. See, in Torah, a day is 24 hours, and for Hilchos Kidush Hachodesh, it's 24 hours equally, which means we assume every day begins at 6 p.m. So whatever time you're going to get once you reach your day is the position of the sun and the moon for 6 p.m. The problem is, even here in Los Angeles, sunset varies. It's not always at 6 p.m. In the summertime, sunset is at 7 p.m., let's call it. Wintertime, it goes as early as 5 or even earlier. So when you're looking for the moon, you have to look for it after sunset, not after 6 p.m. If it's the summertime, 6 p.m. is still day. You're not going to see the moon during the day. If it's wintertime, it's an hour after sunset. So the moon might have already set on the horizon. So you have to adjust for the time of slightly after sunset. So again, 3 steps. Using the daily rate of progress, get the position of the sun and the moon for your day, then adjust that position for your view from Earth, and then adjust that position further for the time of slightly after sunset for your specific day. That applies, those 3 steps apply both to the sun and to the moon. Today, Perek Yud Beis and Yud Gimel, we're going to deal with the sun, and Perek Yud Daled, we're going to deal with the moon, as well as Tezvav, Tezayin, and Zayin is all going to be moon occupied. Let's first talk about the sun. We know the rate of progress. We're going to get that in the Rambam, and you can reach any day. Now, the question is, and I want to share the screen for a second here. Share this. Here we go. So when it comes to the sun, we know the rate of progress, so we'll be able to reach our day with ease. Just find how many days passed since our starting point when we get to where the sun is. The problem is, as we see in this picture here, the sun's orbit is off center, which means that, for example, here in this picture, the sun is at 30 degrees on its orbit. So relative to the center of its orbit, which is right here, you're going to see it at 30 degrees in this little circle. But if you're standing on Earth and you draw the line forward through the sun, notice in the Galgal HaMazalis and the ecliptic in the back, you're going to see it at 25 degrees. Let's go a little further in the month, but further in the year, essentially. The sun is now at 60 degrees. And now from Earth, the difference increases. It's at 50 degrees. Going further, now it's at 90 degrees. But from Earth, it's going to be seen even before 80, which is even more than 10 degrees. Let's go even further, way further. Now we're at 270 degrees. Notice over here, from Earth, it's going to be seen past 270. See, once we pass the 180 degree line, instead of the Earth giving us a lesser angle, the Earth is going to give us a greater angle.
So you said 2 of the seasons.
So 2 of the seasons it'll be behind, 2 of the seasons it'll be ahead, and when you're at 0 degrees and 180 degrees, you're going to see it exactly. There's going to be no differential. However, it's got to always get a little more confusing. The however is that this orbit, the sun's orbit itself, is actually moving. So it's not like you can say, you see here in this picture, 0 degrees of the sun's orbit and 0 degrees of the ecliptic are aligned. So when it's at 30 degrees, we say it's 25. When it's at 60, we say it's at 50. But the truth is that this point of 0 degrees is also moving along the mazalis. So just because in this photo, 0 and 0 are aligned, later on in the world's history, this 0 here was aligned with 60 degrees. So the adjustment has to factor that in. You follow what I'm saying?
Yes.
Which basically means when you want to adjust the sun's position for the view of Earth, you need to first figure out its relationship with its 0 degrees. This is called the goiva. The point of the sun's orbit that's furthest from the earth is called the apogee in English, the goiva. So you need to first figure out how far is the sun from its goiva, and then you can figure out the adjustment. Just like when 0 and 0 were aligned. When it's at 30 degrees, the adjustment is 5 degrees. When it's at 60, the adjustment is 10 degrees. When it's at 90, etc. So what you have to first figure out is where is the sun relative to its own apogee, and then you can say, 30 degrees from that, it's an adjustment of 5 degrees. 60 degrees, it's an adjustment of 10 degrees, etc., etc.
In its own good, was that like by?
That was right by creation, yeah. So what the Rambam is going to do is he's going to give us the position of the sun and the position of its goiva, so that we can know the daily rate of progress of each. And then on our given day, when we want to figure out when the Mailad is, we're going to have to figure out the relationship between the sun and the goiva, and then create the adjustment based on that relationship. If I'm not clear right now, it's going to become clear in the course of the halachas. So let's get right to it. Perek Yud Beis, halacha aleph, and I've only spoken about the sun, but we'll speak about the moon when we get to that point. So Perek Yud Beis, right in the beginning, the Rambam tells us Mahalach Hashemesh Ha'imtzoi B'Yom Echad. The daily rate of progress for the sun, and Ha'imtzoi, mean or average, means in its own orbit. We're not even talking about adjusting the view from Earth just yet. We're first getting a daily rate of progress so we can reach our day. How much does the sun travel on its own orbit every day? Shu arba be'esrim shoyes, which is 24 hours. Tisha b'chamishim chalakim u'shmeina shniyos. 59 minutes and 8 seconds. It's not even 1 degree per day. Just shy of 1 degree. 1 degree is 60 minutes. This is 59 minutes and 8 seconds. Simonam chav dalid matach. For 24 hours, it's nun tes 59 and ches seconds. Nimsa, if you do the math, it comes out. Mahalacha ba'asara yamim.
59 minutes is of space.
Of space, yes, exactly, not of time. 59 minutes of space. Nimsa mahalacha ba'asara yamim. So in 10 days, it comes out to Teisha Milas, ve'echad v'chamishim chalakim, 9 degrees and 51 minutes, v'shalish v'esrim shniyas and 23 seconds. Simanam tes nun aleph chav gimel. In 100 days, it comes out to be 98 degrees, 33 minutes, 53 seconds, 98, 33, 53. And it comes out the remainder of its path on 1,000 days. Why does Ram say remainder? Because in 1,000 days, it'll definitely travel 360 degrees, and we don't care about that. Once we're at 360, we're back to 0. So the remainder of its travel in 1,000 days is after you throw away every 360 as we explained, will be 265 degrees or 38 minutes and 50 seconds. It comes out the remainder of its path. After 10,000 days, 136 miles, 28 minutes, 20 seconds. On this path, you can double and find its path for any number that you want. By the way, the Mefarshim point out that if you do the actual math, you'll see that the Rambam's progress for daily and 10 days is a bit more than its actual, than what the Rambam says. The Rambam kind of rounds it down. In truth, it moves a little bit more, but at 100 days, 1,000 days, and 10,000 days, the Rambam factor that in and give you the precise amount. So just pointing that out. The Chaim says the Rambam, and so too. If you want to make your own signs, that it should be known for you, for its path, 2 days, 3 days, 4 days, whatever you want, pass it. You can make those calculations. And so too, you want to make your own signs to know for 20 days, 30 days, 40 days, till 100 days. You can also do that. It's very obvious. It's revealed and it's known. But once you know the process, the progress for 1 day, and you add as many days as you want, make your own groups. Then the Rambam says, I'm going to give you another group. I gave you 1, 10, 100, 1,000, and 10,000. I'm going to give you another 2 units of time. It's very fitting that you should always have prepared and known the path of the Emtza Hashemesh. Again, this terminology means the sun on its own orbit. You should know them for 29 days and for 354 days, which is the days of the lunar year when its months are alternating in order. Because Cheshvan and Kislev could be 29 or 30. When they're going in order, it's 354. So it's good to have the numbers for 29 and 354. Why? Because 29 days is the amount of days between one sighting of the moon and the next. So it's just good to be able to fast forward months in quick ways, and so too by years. It's just easy for the system. When you have these numbers ready, it'll make it very light and very easy for you when it comes to seeing the new moon. Because there's going to be 29 whole days from the night of sighting to the next night of sighting. It's a little bit more, 29 and a half days, but nights, it's 29 nights. There's no less 29 days, no more 29 days. So 29 days is a great number to have. Because our entire, what we're seeking with all of these calculations is only just to know the sighting. And so to from the night of sighting in this month to the same month in the next year is going to be a Shana Sdura, 354 days, or one additional day or one less day, depending on Cheshvan and Kislev. But the point is, 354 is a great number to have. So what are those numbers? The mean rate of progress of the sun for 29 days is 28 degrees, 35 minutes, and 1 second. Siman Chavches Lamed Hey Aleph, those are the numbers. And its path for a full year is 348 degrees, 55 minutes, and 15 seconds. So now what we've done is essentially given us the rate of progress. That's all we know right now. The next thing we have to do is apply that and reach our day when we want to see the moon. But before that, like I mentioned, since part of the adjustments for the sun is going to factor in the goiva, the apogee, the fact that the sun has traveled away from its furthest point from Earth, and that apogee itself is moving. So the Rambam is going to give us the apogee's daily rate of progress. We spent one halacha on the sun's rate of progress. Now we're going to go to the apogee's rate of progress. Nekuda achas, there is one point, says the Rambam, yesh begalgal hashemesh, on the orbit of the sun. V'chein b'shar galgalei hashiva kechamim, and the truth is, it's all 7 planets, because we said yesterday in the end of Rambam that all 7 planets are off center. So there's one point in all of the 7 planetary orbits, when the star reaches that point, or some versions have kol ma'oidoi. It's going to be distant from Earth at its maximum. It's at its maximum distance from Earth when it's at the apogee. And that point of the Galgal HaShemesh and all the other stars, besides for the moon, this is a very interesting point, besides for the moon, also moves at an equal rate of progress. In other words, the sun's orbit, think about a pizza pie within another pizza pie. So if you have one pizza pie like this, and then the other pizza pie is smaller inside of it, but it's off center, imagine somebody was moving that pizza pie around inside the inner circle. So its point where it's furthest from the center is always moving. Same thing with the orbit of the sun. That little circle that I showed you before on the screen is moving around within the Galgal HaMazalis. It moves very, very slow though. In about 70 years, it only travels 1 degree. So ever since the beginning of history, it really hasn't traveled a lot. Nevertheless, it's important to know because you have to know where the apogee is so that you can figure out the correction based on the distance between the sun and the apogee. This point on the sun's orbit is called the height, or in English again, the apogee of the sun. What is the rate of progress for the goiva? Notice he doesn't even give us the 1 day thing because it's so negligible that it wouldn't help. So 10 days is like the smallest unit we can give you. Its travel in 10 days is shnia achas v'chatzi shnia, 1 second and a half a second. It's a 60th of a degree. Shehi, which that second and a half a second is shleishim shlishiyos, right? 30/3, because a half a second would be 30/3. Nimtza mahalache b'me'ayim, so in 100 days it travels chamish esrei shniyos, only 15 seconds, which is a quarter of a 60th of a degree. And then 1,000 days it travels 2 minutes and 30 seconds. In 10,000 days, which is almost 30 years, it only travels 25 chalakim. Again, the important dates, every 29 days is Arba Shniyos V'Oid, 4 seconds and a bit, which actually, if you do the math, it's 21 thirds. And in a year of 354 days, it travels 53 seconds, which I'm again rounded off because it's a little bit less, by 6 thirds. Okay, so we have now the daily rate of progress for both. Now we need the next step. Now we need a starting point. See, we can't do the math now from year 0 and start going every single day till we reach 5782. So the Rambam, as I said yesterday, made a shnas ha'ikr, a beginning point, where for all calculations, I've already done the math from the beginning of history till now. You can use the now and continue the progress. You can also make your own shnas ha'ikr if you want. Today we're living, much later in history. We can do the math and figure out all the rates for today's day and age. But the Rambam has a shnas ha'ikr, which is in his own time, the year 4938. So the Rambam says, we've already said, at the starting point from which we begin all the calculations is it's from Wednesday night, the beginning of Thursday, the 3rd day of the month of Nisan, 4938 since creation. So let me tell you, based on the rate of progress that I've given you, where is the sun and where is the goiva, where is the apogee of the sun at this night? The place of the sun in its mean orbit. That was at this starting point, was at 7 degrees, 3 minutes, 32 seconds from the mazel of Aries. In other words, it was just after 0 degrees. Mazel Tala begins at 0 degrees. It's 7 degrees in. Simanon Zag Lab, 7:3:32. Where was the apogee of the sun? Was further in. It was in the mazel of Gemini, and it was 26 miles, 45 minutes, and 8 seconds. Simanon Chavav Memhei Ches. So now, when you want to know where the sun is on its mean path at any time that you want, just take the number of days that passed from the starting point till the day that you want. Based on the yamim and you will receive its mean path based on the marks that we gave you. Add it to the starting point. The kabitz call connect every ratio with its minutes with minutes, degrees with degrees, etc. What results is the place of the sun. Ketzad, for example. We started on Gimel Nisan. We want to know where's the sun now in the beginning of Shabbos, 14 days into Hachodesh Tammuz. Very interesting. We're today, Chafalaf Tammuz, just a couple of days away. Chabeis Tammuz. Matzano, we find Minyan Hayamim, the days that have passed from Gimel Nisan, the Yema Ikra, Tchilas Hayem Azesh on the Reitzim Leidam Mekem Hashemesh Bay, Me'ayim, it's 100 days. Oh, we already know 100 days. And we have taken the number of the progress from 100 days, 98 degrees, 33 minutes, and 53 seconds. We thought we added it to the starting point, which is Zag Lamed Beis. The result calculates to 105 degrees, 37 minutes and 25 seconds. And we now can reach where was its path? The Mazel Sartan in the Mazel of Cancer, 15 degrees in, and 37 minutes of the 16th degree. Now the Rambam says the following point. The result that you're going to get from these calculations is the sun's position for 6 p.m. because Torah has, again, 24 equal hour days. So when we say daily rate of progress, we mean from 6 p.m. to 6 p.m. So what you're going to get, says the Rambam, essentially is pa'amim yiyeh b'tchilas layla b'shabbat. It will actually come out to the beginning of the night in spring and fall when days are pretty much equal. 6 p.m. is the time of sunset, so you're getting the position of the sun for the beginning of the night, beginning of the day. But in the summertime, it could be an hour before sunset. Wintertime, it could be an hour after sunset. Shouldn't we have to adjust the sun for after sunset? Says the Rambam, when it comes to the sun, don't worry about that adjustment. We're going to make up for that. We're going to compensate for that when we reach the moon's daily rate of progress, the end of Perek Yudalet. And therefore, based on this calculation, you can do for any time that you want. Doesn't matter, 1,000 years, it doesn't change. The pace of Ikr, gather all the remainders, add it to your starting point, you will reach the mean position. You can also do so with the mean progress of the moon. And any planet, once you know how much travels in a day, Shouldn't be taskling, the starting point. With the kabitz malacha, and you gather up all its progress for those years and days. The taste of Allah Ikra added to the starting point, so you will reach its position in the mean path. So you can do the apogee. Taste of malacha, just add the years, days and years to the starting point. You will get the result of the place of the apogee. You want to make your own starting point, it's also no problem. Besides, for our starting point in this year, so that could be for you at the beginning of a 19-year cycle, the beginning of a certain century. You can do that. Let's say you don't like my year 4938. You want to go backwards in time. A different starting point. After the starting point, it's simply easy. What's the way? You know how much it progresses in a year and in 29 days. And then one day. We know that a practical year is either one day more or one day less than Shana Kesidra. So you know that a leap year is if its months are alternating. It has 30 days more than a regular year. In that Ibra year, that this year we're complete. Will be 131 days over the regular year. 29 days more. And basically, you have all the numbers. And once you know these facts, you can reach the sun's position for any year and day that you want. The taste of Allah Ikar Shasino and add it to our starting point. And you will get its mean position for the day that you want from the previous years. Make that day your starting point. Or you can subtract it from the starting point which we made. When you will get the starting point for the day that you want from past years. So you can make that day the Ikar starting point. And again, you do the same with the progress of the moon, any other planets. If you know their daily rate of progress. You've already you can get from what we're saying. But the same way you can know the mean position of the sun for any future day, you know it for any past day. It's just adding or subtracting. This is simple arithmetic. It's really not complicated. So we now have the daily rate of progress for the sun on its own orbit and the daily rate of progress for the actual apogee, which is causing the entire orbit of the sun to move.
How does the Rambam know that rate?
How does he know that rate?
You could do the calculation backward or forward as long as you know the rate.
Yes.
And he gave us a rate.
He gave us a rate.
Where did he get that rate?
He observed it himself. He spent time observing it. And based on mathematical calculations, he arrived at that conclusion.
Huh.
Yeah.
So they got a telescope or whatever it was?
Whatever they had, the protractors, I don't know how they did it.
Okay.
It's like Stonehenge. They have like ways of.
By the way, if you want to know, yesterday we looked at a more exact solar year is 365 days, 5 hours, 997 halakim and some, whatever. Today it's modern science, based on their calculations, has arrived to a figure, I think 10 seconds less than that. So we're talking pretty exact.
I think they set up markers in the ground and
Yeah, they had their ways.
Like they had the pyramids. The pyramids had certain lines with the stars and the sun.
Medieval science.
Yeah.
It's fascinating.
Yeah.
Really?
So we've done step one. Remember, to find the answer to our question of whether the moon will be set, we have 3 steps. Get the daily rate of progress and reach our day. Then we have to adjust the viewing from Earth and then adjust the viewing for the time of sunset. So with the sun, there's no adjustment for sunset time. We said before, it's negligible. We have the progress. Now we have to figure out the adjustment from Earth. So the Rambam says in Perek Shleisha Asar, you want to achieve the true position of the sun, and true again means relative to the view from Earth, because that's what matters. People are observing the moon and the sun from Earth. If you want to know that point, you must first reach its mean position based on the way we explained by the average daily rate of progress. We're in Perek Gimel Halacha Aleph. And then find the apogee of the sun. Then you must subtract the location of the apogee from the location of the mean moon, which means that's going to give you the distance between the two. The Hanishar, the remainder, Hu Hanikra, Maslul Hashemesh, is called the path of the sun. In other words, how far it has traveled from its apogee.
Can you repeat what's the end of Halacha Aleph? What do you do? What's the first step?
You find the sun's position for your day.
Yeah.
And you find the apogee's position for your day.
Okay.
Then you subtract the apogee from the placement of the sun. because we always look at the sun as ahead of its apogee. How far did it get from the apogee? Between 0 and 359 degrees away from the apogee. That distance is called Masal HaShemesh. So for example, in the Rambam's case, right, we knew that the Goiva HaShemesh is in Mazel Ta'imim. It's like 80 and something degrees into the ecliptic. And the sun, let's say, is 180 degrees into the ecliptic. So it's 100 degrees away from its Goiva. That's the number that we care about. How far has it traveled from the apogee?
I know where the position of the sun is because I can mark that. How do I calculate the apogee?
He gave you the rate of progress in Perik Yud Beis, and you just figure out what day you're at, add the numbers, and you'll get the apogee.
So in Yud Beis, they told you how to calculate the apogee.
Yeah, just the progress.
You just didn't know it. It's a certain unit per day.
And he gave us the starting
per year.
And he gave us a starting
okay.
point. So once you have that, you just keep going. When you reach
Gotcha.
your,
So it's
you
something
reach
you
your goal.
calculate based on the other position, then you know you calculate the apogee
And then you figure out, and then you correct the angular distance. That's basically what it is.
Okay.
The tira, and you will see, and Allah says that how many degrees is this path? In other words, how much distance has the sun traveled from its apogee? And follow this, please. If the path, i.e. the distance, was less than 180 degrees, I'm going to give you the correction. Menas means angular correction. I'm going to give you the correction, and you're going to subtract it from the sun's position. Because again, as we saw in the pictures in the beginning of the class, until 180 degrees, the sun is always observed as behind from the earth. Should I read that up again, those pictures? I'll show it over here. See, the sun here has traveled 30 degrees from its apogee. So observed from Earth, it's going to be seen at 25 degrees behind. So it's going to be behind its apogee. Same thing, you move to 60 degrees. In the ecliptic, it's going to be observed at 50 degrees. Same thing, you go to 90 degrees, it's observed at 80 degrees. But once you hit past 180, see here at 270, now it's going to be seen past 270, not behind, because on this half, it's always ahead. So that's why the Rambam says, if the distance is less than 180 degrees, I'm going to give you the correction, and you're going to subtract it from the place of the sun, because the sun's going to be seen behind. But if the path of the sun is more than 180 till 360, then you're going to be toisif menas hamaslo al makom Hashem Hashem. So you're going to add the angular correction to the position of the sun.
So 180 and 180 matches up, and 0 and 0 match up.
Right? Let's call it 180 and 0 instead of 180 and 180. Just if the sun is at 0 position on its orbit,
Yeah.
then no matter where the apogee is, it's going to be seen from Earth directly, because it's like you're looking through the center. See, if the sun is here, then a person standing on Earth is going to be seeing through the center of the orbit, straight here. So it's not going to be any difference. Same thing with 180. It's only when it's between that there's an angular difference.
Got it.
So if it's more than 180, you're going to have to add it. Whatever the result is going to be after you add or subtract, is the true place. And the Rambam says exactly what he said just now. Halacha gimel v'da, and you should know. If the distance is exactly 180 degrees or 360, i.e. 0 degrees, it has no angular correction. Whatever position you reach in the sun's orbit, that's the true position. That's where it'll be observed from Earth as well. So what is that correction? The Rambam's going to, you trust him, he's going to give you the math. If the path, in other words, the distance between the sun and the apogee is 10 degrees, the correction is 20 minutes. And again, since it's less than 180, it's subtracting it by 20 minutes. If it's 20 degrees, the angular correction is 40 minutes. For 30 degrees, it's 58 minutes. For 40 degree distance, it's a 1 degree, 15 minute correction. For 50 degree distance, the angular correction is 1 degree and 29 minutes. For 60 degree distance, it's a 1 degree, 41 minute correction. For 70 degrees, distance. It's 1 degree and 51 chalakim. For 80 degree distance, it's 1 degree 57 minutes. This is the furthest distance. This is the furthest correction. It's 1 degree and 59 minutes. Once you go back past 90, it continues to decrease. For 100 degrees, it's 1 degree and 58 minutes. 110 degrees of distance, its correction is 1 degree and 53 minutes. 120 degree distance, the correction is 1 degree 54 minutes. 130 degree distance, it's 1 degree and 33 minutes. 140 degree distance, it's 1 degree and 90 minutes of correction. And if it is 150 degrees, the angular correction is 1 degree and 1 minute. For 160, it's 42 minutes. 170, it's 21 minutes. If it's 180, there's no angular corrections. We already explained. And now the table has been given from 0 to 180. There's not going to be a table from 180 to 360. You know why? Because it works backwards. It's proportionate. If the distance was more than 180 degrees, just subtract that number from 360 and you will know its angle. What does that mean? Let's say the sun traveled 200 degrees away from its apogee. Subtract 200 from 360. So you have 160 degree is the remainder. We already know that 160 degree distance, the correction is 42 degrees. And so it will be 200. You can see it maybe on the screen over here a little clearer. 0 is the furthest point from Earth, right? So this half, call it a pizza pie. Okay, this half of the pizza pie and this half align equally in a backwards fashion. In other words, once you're at 180, let's say, going 10 degrees this way, 10 degrees that way is the same angular distance. Once you're at 0, 10 degrees here, 10 degrees there is the same angular distance. So once you know 1 to 180, you just go backwards from 180 to 360. Halacha Vav. Let's say it was 300, another example. Subtracted from 360. You have 60 left. That you already know. Is that the correction for 60 degrees is 1 mila. And 42 minutes, 41 minutes. The same thing will be for every single number. However, the Rambam has only given us the corrections for tens. What do you do if it's in between the tens? Let's say it was a 65 degree difference. We already know. So algebra, right? 60 degree distance, the correction is 1 degree and 41 chalakim. So you fill in the missing number, do some math. So between the two angular corrections is 10 minutes of correction. Well, if you so according to the number of degrees, every increasing degree gets an increasing minute of correction. So for a 65 degree distance, the correction will be 1 degree and 46 minutes. If it was 67 degrees, the same thing. The correction will be 1 degree and 48 minutes. And the same thing will be anytime you have units of ones with tens, whether it's the sun or the moon's calculation. And now the Rambam, as he does throughout all his halachas, is he applies it to his case. Ketzad, how will we apply this practically? Remember, the Shnasa Iker is Gimel Nisan 4938. We want to know for Yud Dalet Tammuz 4938. Figure out the position of the sun, its mean position for this time. The Simonoi Kuf He Lamed Zayin Chav Ches, which is 105 degrees. K'moshe V'Arnu, as we already said in the previous Perek. The Teitzi Mekayim Geiva Hashemesh Le'es Hazayis. Then you want to reach the apogee of the sun for this time. It's at 86 degrees. You subtract the apogee from the position of the sun, 105 minus 86. The path of distance between the sun and the apogee is 18 degrees, 52 minutes, or don't care about the minutes. Just focus on the degrees. So with less than 30, less than half of a degree, just ignore them. If they were 30 or more, put them into 1 degree. The taste of Isa, minyan, milas, and masl, and add it to the degrees of distance. The fichach, in this case, where it's 18 and 52, we're just going to call it 19. Call it 19 degrees of difference. The Tia Manasel that I should be based on our calculations, it'll be 38 minutes. Why 38 minutes? Because we know the number of 10 and we know the number of 20. Based on the rate between 10 and 20, we know that 19 is 38 chalak. Since our distance was less than 180, we have to subtract the angle, which is 38 chalakim, from the position of the sun. Yishar, we now remain with 104 degrees, 59 minutes. This leads us to the conclusion that the Mazel Sartan, at the true position of the sun at the beginning of this night was in Cancer, 15 degrees in, less by 35 seconds. Again, in this case, do not care about the seconds, not the sun, not the moon, not any other calculation. The maximum you should be dealing with is the minutes. If you find that the seconds are close to 30, just make them into just make it another chelik and add it. And final halacha, once you know where the position of the sun is for any time you want, you will now know the true day of the tkufa, any tkufa that you want. Remember yesterday's Rambam, we talked about dividing the solar year into 4. There's 4 seasons. But those 4 seasons were dividing the seasons equally because we were looking only at the sun's position in its own orbit. Now that there's a bit of a correction, so we can now know when the true tkufa will be. When will the sun truly enter 0 degrees relative to if you were on Earth? When will the sun truly enter 90 degrees, etc., etc.? Because once you have the true position of the sun, you know the true tkufa. Both tkufas that are coming and tkufas that have passed. Just to summarize again, that this point here. In this picture here, what we want to know is where is the sun going to be seen against the ecliptic? We don't care where the sun is in this orbit. We care where a person on Earth is going to observe the sun against this backdrop. Now, since the sun is moving along this orbit, we first need to know where is the sun on this orbit. Before we go for our view, we have to know where the sun is relative to its own orbit. So we figure that out. Then we can't just suffice with this because the world doesn't always look this way. The apogee isn't always here. What's making this difference here of 90 degrees versus 85 degrees is not the position, it's this distance. This distance of the sun from its beginning to 90 degrees is what's causing that difference. So if this entire circle moved, if the Goiva, let's say, was at 60 degrees, okay, relative to the ecliptic, so then the 90 degree difference will create this difference over here, not over here, because it's all about where the sun is relative to the apogee. That's why the whole Perikid Gimel was occupied with that, finding the distance between the sun and the apogee, because once you have that distance, you can correct the angle.
When he's talking about not calculating the seconds,
Yes, not calculating, the seconds.
he's saying he's not saying that if you're calculating from his 4,300 to our 4,700,
4,938, yeah.
I mean that's 700, 800, 900 years.
Yes.
Now
So
you're going to need the seconds.
you need
for
to,
that.
yes, of course. When you're getting the position for your date, you need to calculate the seconds till you get there. But once you reach your date,
You're trying to calculate the difference in the apogee.
then you don't care about the seconds. Yeah. Mendel, can I send you one more thing maybe for a screen share? Okay. So I'm going to take 1 second here. Okay, here we go. Copy the link. Okay. How do I find it? To go into your email over here?
Yeah.
Oh, perfect. No? Or is it not finding it?
Takes a minute.
Oh, here we go. Okay. Let's see if we can see the screen over here. Very good. Okay, take a look at this photo here. How do I? Sorry about that. Okay, I can continue now?
Yeah.
Okay. All right. So Perek Yud Beis and Gimel were all occupied with the sun. Now we're moving in Perek Yud Daled to the moon. And again, when we want to figure out where the moon's position is, we're going to follow the 3 steps. First, find out the daily rate of progress and reach our day. Then we have to adjust for a couple of things. With the sun, it was one adjustment, just for the view of Earth. We're going to see with the moon, it's much more complicated than that. But before we even get there, we need to figure out the daily rate of progress. The daily rate of progress itself is a headache. Okay, with the sun, it was simple. The sun moves along its orbit, finished. You give me the number for how much it moves in a day, I come to our day, and I'm done. With the moon, we start with the following premise. Here in this photo, you can see this outer circle is the moon's orbit. However, besides for the moon circling the Earth in this orbit, it's also hopping around in this mini circle over here. Okay? So when we figure out the moon's rate of progress, we have to figure out 2 things. This little circle is called the epicycle in English. And this epicycle moves along the circumference of this orbit. So you're following the entire little circle is moving around the big circle. And in the little circle, the moon is hopping around. To make it more confusing, the epicycle is moving counterclockwise around the orbit. And in this little circle, it's moving clockwise. All right? So we first need to know what's the epicycle's rate of progress along the bigger circle. That's going to be called in Perek Yud Daled the Emtza Hayareach. And then we have to know what's the moon's progress on the epicycle. That's going to be called the Emtza Hamaslo. Okay, so even for the daily rate of progress, that's the first thing we have to know. Then we're going to have to, later on in tomorrow's Rambam, we're going to have to correct the distance between the Emtza Hamaslo and the Emtza Hayareach. You see in this picture over here, here's the moon on the epicycle to the right of it. So if a person was looking at an Earth and he only knew the position of the epicycle, he would think the moon is over here. But because the moon on its epicycle has gone a little this way, the true observation is going to be over here. Same thing in this picture, the other way around. The moon is further on its epicycle, you're going to see the moon further in the ecliptic. So we first need to know where is the moon on this circumference, and where is the moon on its epicycle. Then we're going to correct the distance between them. Okay? Let's go for the Rambam. Stop the share. Perek Yud Daled halacha aleph. Hayareach, the moon. Shnei mahalachim emtzoyim yesh lo, has 2 average rates of progress. 2 before we get to the Earth, just for itself. It's got 2 simultaneous motions. Hayareach atzmai, the moon itself, misabev begalgal katan, is turning around in a little epicycle. She'enei makif es ha'olam. This cycle does not surround the Earth kulai entirely. Umahalachei ha'emtzoi ba'isei hagalgal katan. Its progress on that little cycle, nikra emtza hamaslo, is what we're going to call the mean path. But the entire epicycle, misabev big galgal, is circling in a big orbit, which surrounds the world. And that progress of the entire epicycle along the circumference of the larger orbit, is called the Emtza Hayareach. So we have 2 simultaneous paths to deal with the moon. Says the Rambam, I'm going to give you the daily progress of both. Let's talk first about the progress of the entire epicycle. In one day, is 13 degrees, 10 minutes, and 35 seconds. By the way, when we say the progress of the epicycle, the way we're going to measure it is the center of the epicycle. Where is the center of that big circle along the orbit? So the center point of that epicycle moves 13 degrees and some per day.
There's no point in calculating from the moon because the moon is moving it.
That's right. You can't calculate. Exactly. You have to get it from the center. Nimsa mahaloche ba'asara yamim. So now in 10 days, based on that math, do some addition, is me'ah v'achas u'shleishim ma'alos v'chamisha v'arbaim chalakim is 131 degrees and 45 chalakim v'chamishim shniyos simonam kuf lamed aleph mem hey and nun. The nimsa she'edis mahaloche b'me'ayim, the remainder of its progress. And again, here we have already at 100 days we have the remainder, because in 100 days it's going more than 360. So the remainder of the progress is Masayim, 237 degrees and 38 chalakim, Shalosh Vasim Shniyos, Simonam Reish Lamed Zayin Lamed Ches Chav Gimel, V'nimtzeis, and it comes out She'edis Malachet Elifim in 1,000 days. The remainder of its progress is Masayim, 216 degrees, Ushlesh Vasim Chalakim, Chamishim Shniyos, Simonam Reish Yudvav, Chav Gimel and Nun. V'nimtza she'edis ma'alache ba'aseres lafim yom in 10,000 days shalish ma'alash shmena b'chamishim chalakim ve'esim shniyos simonam gimel nun ches and chaf. And again, we return to the fundamental numbers. V'nimtza she'edis ma'alache b'tisha v'esrim in every 29 days. What is the remainder of its progress? Is shtayim ve'esrim ma'alash tisha chalakim just 22 degrees because it makes really 360 plus 22 and 6 chalakim v'shish b'chamishim shniyos 56 seconds. Simonam chav days vav nun vav. V'nimtza she'edis ma'alache b'shanas duda in 354 days is shleish meis v'arba v'arba milas 344 degrees. Shisha v'esrim chalakim shalosh v'arba shniyos 26 minutes and 43 seconds. Simalahem shadam chavlav and gimel v'al derech zu. And from using this concept, you can tichpol, you can double up l'chol min yamim aishanim shtirtza any amount of days or years that you want. Again, like by the sun, when it came to the daily and the 10-day progress of the moon, the Rambam rounded it down to a bit less. It's a bit more, but he factored that in when he gave us the 100, 1,000, and 10,000 numbers. He gave us the precise amount. And
so the sun in one day travels less than 1 degree.
the moon is 13
The
degrees.
moon is over 13.
Right. But it's not the moon itself, it's the epicycle of the moon. There was a center for it, 15 degrees per day. It's much faster. Right. By the way, yesterday's the Rambam says that when it comes to the moon, you're going to notice inaccuracies. These are one of the examples of the inaccuracies. The Rambam is rounding down numbers left, right, and center because he knows that in the end, it's all going to come together. So you don't have to worry about that. But we're doing the math, so I'm just letting you know that for the 1 day and 10 days, it's a little bit, it's not fully precise. So that's the daily rate of progress for the center of the epicycle. Halacha Gimel Perek Yudal. Now let's talk about the path of the sun, of the moon on its epicycle per day. And remember, this path is clockwise, not counterclockwise. This goes also 13 degrees, 3 chalakim though, and 54 shniyos. Simonam Yud Gimel Nun Dalet. Nimsa Mahalache Ba'asara Yamim in 10 days. Meo Shleish Ma'alos Tisha Shleish chalakim. 130 degrees and 39 minutes, without any seconds. It rounds out perfectly. Simanam kufla amid lamites. The nimtosh edis malach and it may in 100 days. Masayim v'esrim milas. Tisha v'esrim chalakim v'shalosh v'chamishim shniyos. We got 226 degrees, 29 chalakim and 53 shniyos. Simanam reish chavtes nun gimel. The nimtza she'edis malach elefim in 1,000 days. The remainder of its path is mea v'arba milas 104 degrees. U'shmeinu v'chamishim chalakim v'chamishim shniyos. 104 degrees, 58 chalakim, and 50 seconds. Simanam kuf dalid minches nun. The nimtza she'edis ma'alache v'aseres lafim yom, and in 10,000 days it's shleish meis v'tesha v'esrim milas, 329 degrees. Shmeina v'arbaim chalakim v'esrim shniyos. Simanam shin chavtes memches and chaf. The nimtza she'edis ma'alache v'tesha v'esrim yom. In 29 days is shmeina v'esrim milas or v'chamishim chalakim v'arba shniyos, 18 degrees. 53 chalakim in 4 seconds. Simanam yudches nun gimel dalid. Halacha dalid. The nimsa she'edis malacha r'shanas duran. In a year, it's shleish meis v'chamish milas u'shleish esrei shniyos v'loi chalakim. Simanam shin heyud gimel 305 degrees and 13 chalakim. Very important point of clarity here is in order. I want to show you on the screen over here this epicycle, the emtza hamaslo. Yep. So when it comes to the,
You didn't screen share.
I didn't screen share it. Thank you. Share my screen. There we go. A point of clarity about the Emtza Hamaslo over here. So you can see on the larger orbit, we know where 0 degrees is because we align 0 degrees with 0 degrees of the ecliptic. But because the Emtza Hamaslo is constantly moving along the circumference of the larger orbit, where do we count 0 degrees for this little epicycle? The moon is moving 13 degrees. 13 degrees relative to what? I mean, where's the beginning point? So if you can just think about it, I'll kind of demonstrate it here on the screen. If this is the epicycle, and it's moving along, can I see this clearly? I'll stop the share. If this is the epicycle and it's moving along the circumference of the outer circle, there's 2 ways you could look at it. You can say my phone is going like this. Okay, with its top is always stationary, its bottom is always stationary, or you can say it's going like this. See? And then the top always remains the furthest point from the center. That's how the epicycle works. The epicycle is circling around the larger orbit in this way. So the 0 degree point is always the point that's furthest from Earth. So wherever the epicycle is, we just find the furthest point from Earth, that's 0 degrees. And in one day, the moon travels 13 degrees away from that point. The next day, even though the entire epicycle is moving, that's not going to change the relationship of 0 degrees, the furthest point to Earth. So it doesn't matter. Now it's 26 degrees, now it's 39 degrees, etc., etc. Is that clear? Following? Okay.
We should show it on the map with the actual.
So the thing is, it's not moving, so I can't really, because it's always in this position. It's always locked in here. Maybe those are all PDFs. I can't work with the slides.
Between those 2 slides, it moves.
See which is here and here?
Between the slide, that and the.
This slide?
Those
No,
two,
but
yeah.
here only the moon moves though. I'm talking about the entire epicycle moving. See, when this entire circle moves to here, it doesn't mean that the moon stays down here and it gets swept along. Epicycle is this little circle.
Which is what?
The moon is moving around it's hopping around. Yeah,
And it's moving this. way.
and it's
The
moving
whole
exactly,
thing is moving.
exactly.
One is counterclockwise and the other is counterclockwise.
That's right. One is counter, one is clockwise, exactly. So anyway, this will become much more relevant, much more pronounced in tomorrow's Rambam, but I want to make that point for clarity now, that 0 degrees is always the point furthest from Earth of that epicycle, and it moves around like such, along the ecliptic that way.
Right.
And the moon is, making its way slowly here, so the moon kind of stays, if 0 degrees is here, and the moon went to 13 degrees, and now after a day, the epicycle went here, the moon is still going to be here, not here. Because the moon stays 13 degrees relative to 0.0, which always stays the same. Okay. It's hard without a visual. I wish I could bring out like a movable type of a thing. All right. But that's the daily rate of progress, both for the Emtza HaYareach, which is the entire epicycle, and the Emtza HaMaslul for the moon in the epicycle.
Why in this halacha are these specific things picked? Like 1,000 days, 10,000 days, 29 days?
Okay, so in the beginning of today's, we saw that the Rambam gives us 1, 10, 100, 1,000, 10,000. It's just easy multiples. And then he gives us 29 and 354, because 29 is 1 month, and between every sighting is 29 days. And 354 is just a year, so you can fast forward years easily. All right. Now that Rambam has to give us the position, the current position, starting point. The position of the epicycle, on the beginning of Thursday, which is our starting point for these calculations, it was the Mazel Sher in the Mazel of Taurus, Maila Achas, above Asr Chalakim, 1 degree in, and 14 Chalakim, which is really 31 degrees on the ecliptic. And 34 and 43 seconds. Simanam Aleph Yudal and Gimel. The Emtza Maslul, Haya Be'ikr Zeh, was on this starting point, Arba Ushmain Milas, 84 degrees. But not 84 degrees like you might think, 84 degrees going counterclockwise, 84 degrees going clockwise from point 0. So once you know the progress of the epicycle and you know the position of the epicycle, which you have to add on, you can reach the position of the epicycle any day you want. The same way you follow the process for the position of the sun. Now we come to the final point.
You have to either add or subtract one from the other.
Huh? Where?
In other words, once you know where it is in the epicenter, now you're gonna have to subtract where.
Yeah, but that's coming tomorrow.
Oh, that's tomorrow.
That's coming. Now we're making, even before we get there, we're making another correction. Once you reach where the last 2 lines of Halacha Dalet, after you reach the position of the epicycle, for the beginning of the night, remember, you're going to reach the position for 6 p.m. That's the way it works. So now he's bringing Bashemesh. You have to take a look back at the sun, and figure out in which constellation it is. Why are we doing this? Remember, the way to reach the position of the moon or the sun, when you're going to be able to sight it, is you have to first know its daily progress. Then you can correct that daily progress for your view from Earth. The problem with the moon is because it's got 2 simultaneous things, we have to first correct those. Before we can even correct the relationship between the 2, each one requires a correction. We have the epicycle moving on in the bigger circle. We have the moon moving on the epicycle. Both of those need a little correction. Before we discover what you were saying, which is the correction between the 2, each one needs to be more precisely located. So now we're going to precisely locate the epicycle. In tomorrow's Rambam, we're going to precisely locate the moon on the epicycle, and then we're going to correct the 2.
When you mean correction, it's because like what you said before about the 6 p.m. not being the exact.
Yes, that's this correction. What we're coming up to right now is a 6 p.m. correction. What we're coming up to right now is we can't just say that wherever the moon is at 6 p.m., that's where it's going to be when I'm going to see it, because sunset varies from day to day.
And where you are as well.
Well, where you are is always Yerushalayim.
Oh.
All calculations are correct for Yerushalayim. So that never changes.
So these calculations cannot be done outside?
No, they cannot. The Rambam says clearly in Perek Yud Ches. And really also yesterday's Rambam. But it's the same thing. Yeah. For California, it's an entirely different timetable. Because that's not what matters. Well, the only place you could see the moon for sighting would be in Yerushalayim. So that's all we care about.
The Edom that was based on Re'iyah, they had to be somewhere around Yerushalayim.
That's a great. That's a great point.
We're talking about coming from outside the Tzchum and all that. That
On Shabbos, yeah.
So it implies that they are a little further from Yerushalayim.
Yeah. So this is. It's you're getting into some interesting territory.
Okay.
In Perek Yud Ches.
Between about 10 days.
Yeah. So at the end of yesterday's Rambam, we said that it's everything is true for a 7-day radius around Yerushalayim. Shisha Yeshiva Yom.
Like we even mentioned that in Yavama says at the end, Rabbi Akiva he was in Argoa.
That's right. To be Ma'aber Shanim.
Yeah. It's like, wait a minute. How's he doing? Unless
that was different. No. That was for making a fixed calendar. That wasn't for making the Kadosh. That was a different issue. But the point is that the calculations are accurate for Yerushalayim, and it's environs basically. That's so that Edom can come from anywhere around, but not too far out.
We said they have to be within 1 day's travel, no?
We did, but the Rambam says 6, 7. It's complicated.
So this is why when we announce the month, we say the moment in Israel.
That's right.
That's all we care
That's all we care about. That's all we care
about.
about. That's what makes Rosh Chodesh. Everything comes out from Yerushalayim. So when we're going to see the moon here, it makes no difference. All right, let's make this final correction. So we have to look at the sun and know. We have to know which constellation is in. Meaning, when the sun travels along the ecliptic, it's getting north or further south from the equator, right? Because the ecliptic is inclined up to 20.5 degrees from the equator. So depending on where the sun is, which is another way of saying which season it is in the year, sunset will be progressively earlier or progressively later. So if I tell you the epicycle is going to be here at 6 p.m., yeah, but in the summer you have to know where it's going to be at 7 p.m. In the winter you have to know it's going to be at 5 p.m. That's this correction right here.
I'm sorry to ask a stupid question. From the time when Rambam wrote this,
Yes.
until now,
Yes.
has anything changed in the world that would cause this to not be accurate now? Like, for example, climate change?
Not as far as I know.
Okay.
The modern science has different ways of arriving at these calculations. Over time, we've discovered that the orbits are not circular, they're elliptical a little bit. So that throws things off. Gravitational pull, in medieval science, there's no talk about gravity. But yet, it's interesting that Rambam basically accounted for everything. They had a different way of computing it, but it all comes together.
And when he said 10,000 days from now, it's going to be like this.
10,000 days, nothing is changing. The day it was created is the day it's going to be. That's the thing. I read that there was recently a study, some professor tried to do more accurate calculations. It came to the Rambam it came exactly to the same. There was no difference. All right. So figure out which constellation the sun is in. In other words, in English, which season of the year it is. Im hoisa shemesh mechatzi mazel dagim ad chatzi mazel tole. I still share screen? No, okay. If the sun was anywhere between half of Pisces and half of Aries, that means it's basically the end of Adar, the beginning of Nisan. Springtime, taniach emtza hayareach k'maishu. Leave the epicycle as it is. No correction is needed because sunset is pretty much 6 p.m. that time. There's no issue. Ever further into the summer, from halfway through Aries to halfway to Gemini, that's Nisan to Sivan.
Further into the spring.
Further to the spring, I'm sorry, thank you. Getting closer to summer. Add to the epicycle 15 degrees. Because the moon's gonna travel another 15 degrees by the time we're able to sight it. And if it's from the middle of Gemini to the middle of Leo, that's already summertime, Sivan to Av, add also 15 halakim. No, this should be shloshim, I believe. Yeah, it should be corrected to 30. Additional 30 halakim, exactly. If it's from the beginning of Leo to halfway through Virgo, Then you have to add 15 chalakim. From half of Virgo to half of Libra. It's again, it's the fall. And here,
It's 6 p.m.
it's 6 p.m. again. From halfway through Libra to the beginning of Sagittarius, right? You have to now subtract 15 chalakim because sunset is getting earlier. You have to know where the moon will be earlier. And from the beginning of Sagittarius to the middle of Aquarius, minus 30 chalakim. This is the dead of winter. It's the earliest sunset. And from the beginning of Aquarius to the Chatzi, the halfway through Pisces, you have to subtract 15 chalakim. And this is the adjustment for what the Rambam calls Sha'as Hariyah. What the epicycle will be at after you add or after you subtract or after you leave it as is, is correct. The epicycle's position after sunset, the at about a third of an hour, 20 minutes. In the day that you reach the emtza, which is called the position of the epicycle for the time of sighting. So that's what matters. At sunset, the sun has just set below the horizon. The moon is still too light for you to have seen it. The crescent is too small. 20 minutes after sunset, the sun is enough below the horizon. Now you want to know where the moon is. If the moon is high enough on the sky that you can see it, that's good. If it's not, then you won't be able to see the moon. But you have to know where the moon will be 20 minutes after sunset. So that's the Emtza Hayareach, the Shas Hariyah.
But this is not very significant numbers. These chalakim are less than a degree.
Less than a degree. But it's still significant.
It's still significant. In other words, Beis has to know this that the eating come and they say it's in this place and not this place. You can tell that they're lying.
Yes.
Because it's off by the chalakim.
Because off of those chalakim. Yeah. And those chalakim make, especially right at the edge of the horizon, it makes a very big difference to know. Because a difference of a degree, less than a degree, can make the moon more visible or less visible.
So
as we'll see.
20 minutes after sunset.
20 minutes after sunset. So you follow the daily rate of progress to get to 6 p.m. Then you make a slight adjustment to move it back or forward, and the Rambam makes it very round because every day sunset is different. But he makes it into 6 or 7 different units, and that's it. If you leave it alone, add 15, add 30, you get to where it will be at sunset.
Can you just not connect to today's round? Can you give us some insight into the mazalis in general?
The mazalis in general.
Yeah, like why
are we talking about mazalis?
No, like they all have a different name, they all have different significance. Like what's
The Rambam just easily said in Nisan, ER, Sivan. Right?
Yeah.
Right.
Well, we use the mazalis because they were the clusters of stars that were identified by the early sages. That's how. See.
Clusters of stars.
Yeah, that's what the mazalis are real. They're real things.
Yeah.
pre-model?
Huh? Pre-model.
You're saying the actual seeing of those images.
Yeah. Yeah.
No, what do you mean? Even
The
today,
but today you can see some of the shapes.
the
sages were looking.
Is the shape of stars that makes up the
Looks like an ox.
Yeah.
Okay.
Libra.
In other words-
Same thing.
No, hold on. In a certain time of the year, you can see an ox up there?
All year, all the time. If it passes your horizon during the nighttime. See, the ecliptic goes around the earth, so it's only passing your horizon. Only half of the ecliptic will pass your horizon every night.
Okay.
Right?
Yeah.
It's going around fully every day. So wherever you are during your nighttime, you're going to be getting half of the ecliptic.
These stars are fixed in the sky wherever they are,
The constellations?
Yes.
Yeah, they haven't moved. After the Mabul, they moved a little bit. That's our tradition.
What does that mean?
Huh? Part of the chaos of the Mabul was also chaos in the heavens. That's just how it was.
Okay.
So the sun and the moon, they're stars, right? They're hanging in the middle of the sky. You have to have a backdrop to identify their movement. So how do we label where the sun is moving, where the moon is moving? So the sages identified, they found these clusters of, I said, hey, interesting, the moon is always moving along this belt. It's always somewhere along the belt. So they decided to call those the mazalis. Now they believed that they had powers, these groups of stars. So that's where the Avodah Zarah came in. But for computational purposes, it's very, very helpful because, first of all, it gives you a frame of reference. And then if you divide it into 12, you get very specific frame of reference, 30 degrees, 30 degrees, 30 degrees. So it just became an easier way of identifying things, where the sun is, where the moon is. Instead of saying it's at 175 degrees, and you go figure out 175 degrees, say it's 10 degrees into Mazel this. That's it. So you know where it is.
So why not just say the month?
Because the month doesn't match to the constellation.
They're actually half of,
So someone,
No, but
let's say someone's born in Elul, right? So Elul is Virgo, right?
Elul is Virgo, but not currently. You see, in a
Right,
leap
so
year.
our Elul might not actually, part of it. might
Yeah,
not
that's
come.
exactly. And look, and also in leap years, what do? You have an extra month now. Which Mazel is that? The Mazals are the solar path, not the lunar path. So they can't match up to our Hebrew months. Hebrew month is less than 30 degrees. It's the 29 days.
So the Mazalas really are solar path.
Yes, because it takes the sun a full year to get around it. We use them for the moon as well to identify position.
Are we still recording?
Yeah.
Oh, okay.
Just for interesting, yeah. So we use them as always. That's why we use this. We can't use months. Months aren't the barometer. You have to use the king degrees.
So, but there are ways to tell if let's say whatever, when your Hebrew or English birthday in the year.
Yeah, you could know where the sun and the moon were actually. Yeah, of course. What your true mazel is.
Right.
But it doesn't mean that each month corresponds to a certain mazel. It's when you have to figure out when you were in the month, and if it was an Iber Yar or not an Iber Yar, and then you'll see which mazel use these calculations. Literally use these calculations. You figure out where the moon was, where the sun was. That's my mazel. Now I know which constellation I'm born in. Longitude, latitude, mices. It's a whole thing. Okay.
Rabbi,
All right. Tomorrow is a very long Rambam, so I think we need to start at least at 5:30, maybe even earlier.
Look, are you a pro in Hachodesh? Are you like a pro in Rambam? Well, where are you?
Are we recording?
No, we're not recording.
He's the pro in Rambam.
I'm serious.
I've always been fascinated by Kidush Hachodesh, so I'm pretty proficient, but
and you got
Also
your
the Rambam in general.
I'm not gonna toot my own horn. Huh?
You got your training from your father or from
No,
someone
we
else?
both became interested at different times. So it's interesting. Yeah.
So who was your Rebbe on this stuff?
My Rebbe was actually a friend of mine. He when I was in yeshiva, he gave me the book. And that book really is my Rebbe. He's my
Jewish book?
Yeah, it's a book from a guy in Israel. He wrote it, and I read the book cover to cover that year.
Really?
It was a very beginner, like Kidush Hachodesh for dummies kind of thing. And then once you have the base knowledge, so then I was able to read more complex books and more refreshing the Rambam. It's a fascinating world.
Sorry.
That's it. You're good. You're good. Should we end it?
Bruchim to you.